Good afternoon, everyone. I hope you are safe and doing good today. Webinar is on Six Sigma and cost reduction. I am Khushbu Mistry. Your host will be with you for 1 hour. So, talking about CUNIX. CUNIX is a management consulting firm having experience of more than 25 years with 350 plus satisfied clients present in 19 plus countries. CUNIX is CMMI Institute partner organization with 250 plus CMMI appraisals. Also in 2016, we were among top 10 partners of CMMI Institute, USA for new appraisals. Now I'm glad to introduce you to our presenter, Mr. Himanshu Karkhanis. Mr. Himanshu is the Six Sigma Black Belt certified high maturity lead appraiser. Also, I would like to request you to write your queries in the comment box. We shall take them up in the question and answer session at the end of today's webinar. Now, I would request Mr. Himanshu to take over the session. Thank you.
Thank you, Khushbu. And very something between good afternoon and good evening to all those who have joined in. I appreciate your joining in this situation. I'm sure and I hope that all of you are safe wherever you are and from wherever you have joined in. Of course, we all hope that the situation gets better soon. I request some guidelines before we start. I request everybody to keep your Zoom settings on mute and switch off your videos also. If there are any queries, you have a chat box. It will reach directly to me. Please feel free to put in your questions or queries. We shall be recording this session and we will send out information of how you can download and access this recording in the future. So in the meanwhile, I request all of you to please, there's no requirement of recording. It might lead to bandwidth issues at your end since we have multiple participants in this webinar. Also due to the time constraints, if any of your queries are unresolved, then I will still give out the information regarding how you can contact us. So we will be taking up these questions as and when they're coming on the list. And of course, and the last point, but not the least, make the best use of this webinar. So this is a topic. My name is Himanshu Karkhanis. I'm a high maturity lead appraiser and Six Sigma Black Belt professional. And I'm representing the organization CUNIX Infotech Private Limited. I'm happy to connect with all of you. Before we start about the main topics, let's talk a while about what to expect from this webinar. We will provide an introduction to some concepts of Six Sigma and the cost reduction. Remember that it's a very big concept and it's not possible that we cover the whole thing in a matter of like 40 minutes or 50 minutes. Also, we will provide an overview of some Six Sigma techniques which you can use for significant cost reduction as well as identification of some cost factors. Can I request the participants to keep yourself on mute? All right, thank you. So remember that this is focused on how you can use some of the techniques of Six Sigma for cost reduction. There have been, no doubt, many of you must be already having programs and might have dealt with the cost reduction scenarios. in the past, or maybe doing it at present in this situation. This does not aim to be a full-fledged cost reduction course. There have been a lot of researches done before all of us by many people, many great minds, on the best use of some of these techniques, including Six Sigma. The aim of this webinar is to avoid and minimize your time in research and bring before you some of the simplest concepts based on Six Sigma, which could be used for potential cost savings. Also, let's look at what it will not do. So, well, we are not going to have a Six Sigma course for sure. That's not possible. I don't intend to teach statistics again as a full course, but we will look at how you can use some tools like Minitab to use those statistical concepts. And there are many analytical techniques that effectively can be used, many statistical techniques to be very precise. We will be taking only some of them. So let's proceed. Let me start with a very relevant quote for today, or quote of this webinar. Costs do not exist to be calculated, they exist to be reduced. This is so true. And who can say it but none other than Taichi Ono, who was an engineer as well as a businessman. He worked at Toyota. And he was the one who introduced this 7 ways of manufacturing, which so many organizations and companies are using for their benefit. So we'll start by remembering him, and we owe the lean methodologies to this great man. Remember that lean methodology is one important thing that you can use for cost reductions. So Six Sigma, something about Six Sigma now. It was introduced by Bill Smith, actually born as William Smith. This great man was working with Motorola at the time when Motorola had set some high quality goals for itself as a competition to Japanese firms. And it is there where he coined the term Six Sigma along with his co-worker. He was one of the first people to actually use quality as a function of one statistical parameter called as standard deviation. So those of you who might know about standard deviation, he was one of the first one to actually link quality with the measurement of standard deviation. And well, his approach was very simple. If you want to improve something, involve the people who are doing the job. So you can't sit somewhere else secluded from the people and then expect the quality, to improve on its own. Now, you might say, fine, that's fine. So it's a good thing, like for having Six Sigma. But then why do I need Six Sigma? And what about the six? So here, let's look at how the Six Sigma term stands from or comes in. The sigma in the Six Sigma is essentially standard deviation. It's a symbol to denote standard deviation. And what about the six? So the six has a quality expectation that if the distance between the process mean and the nearest specification is 6 standard deviations, then practically everything would conform, or there will be no process points outside the specifications. Let me explain. So standard deviation in simple terms is the distance of each point from the mean. So if and specification limits is something like a target, you all set targets for yourself. It is something that you set or you expect. So if the distance between the mean and the standard deviations on the mean and the specification limits is 6 standard deviation, then most of your points will lie inside those specification limits, and that's from where the concept of Six Sigma comes in. Let's look at a diagram so that might help us to understand more. So here you can see this is called as a normal distribution. The areas over here are essentially the points of a process. And since this looks, well, quite symmetrical, and that makes it a normal, one of the distributions, which is a normal distribution, you have set some limits, an upper limit and the lower limit. And these are the distances. So from the mean to the nearest limit, if the distance is 6 standard deviations, well, then you can expect that all your process points, or most rather of your process points, would fall within the limits, and well, which is good enough. I again request those who have just joined to please ensure that your Zoom is on mute so we can have a smooth webinar. Any queries, please put in the chat box. I will be happy to address them. And some more about Six Sigma. As I said, we may not go into the whole course, but what it says is these are the levels or the ratings of Six Sigma or Sigma. And the moment we reach the Six Sigma, what you get is a quality that talks about just 3.4 defects per million opportunities. Here, opportunity is, each opportunity is a chance where you might make a mistake or there could be a defect. So when you talk about Six Sigma, this is the quality that you're talking about. So it's a performance measure. And this is the famous DMAIC, or these are the phases of Six Sigma. Define, measure, analyze, improve, and control. So this is a combination of change management and statistical analysis. We will be talking about each of these phases. We will be talking about what techniques you can use in each of these phases and how they will relate to cost control. Let's talk about define. In the define phase, you have to define and document your problem statement. So whatever it is that you're worried about with respect to the costs, please remember that you have to write it down. When we are clear about the problem statement, it will help you to define some parameters ahead, and you can use some of these techniques that you're going to see today. For example, you can start with what is your quality requirement and what is their relation with the cost overheads that you're having. You must understand the customer requirements, because for any project in Six Sigma, that's the goal, which is customer satisfaction. You have to define what is the effect that you're targeting, or what is the effect that you want or you desire. I'm sorry for this noise. I just kind of unmuted somebody. So you have to define what effect it is that you are targeting. Also define the target, meaning that you must have some numerical targets in mind, some goals in mind with respect to cost reduction, because cost reduction cannot be infinite. But you must do that without anticipating a solution in advance. Remember, in the define phase, you just define the problem. You are not aware of whether a particular solution would work or not. For preventing some noises, let me please ensure that people can not, so I'll just mute everybody. Okay, so there we are. Also, you have to establish what financial benefits you expect from doing these activities, because cost reduction is a very broad area. So whether you're talking about some immediate cost reductions, whether you're talking about having a financial model that can give you consistent cost reductions, this is what you must establish in the defined phase. So moving ahead, let's talk about the concept of cost reduction. Uh, Let us not confuse it with, a conscious reduction in the budget, because hey, I can always spend less money, right? But that doesn't mean I'm reducing my costs, because if my costs are related with my needs, then they are the essential things. And cost cutting is a different terminology or a different concept. So we are not going to talk about cost reduction or less spending. So it's more about cost control and being aware of what are the things that contribute to a cost. We have people from all walks of businesses and work areas. Some of you may be from the manufacturing side, some of you are from the softwares, some of you are giving some other services, some of you may be having your own businesses, some of you might be working as quality managers. So regardless of that, you must define the problem and you must be aware of the cost factors. And this is what the define phase helps you to do. Let's talk about 7 wastes. This comes from the concept of Lean Six Sigma. The reason why we are talking about these 7 wastes is at the upfront. Being aware of these 7 wastes can actually give you some hidden insight, or an insight into something which was hidden till now, about what are the factors which are really causing the cost reduction or cost being to increase, and how can I reduce the costs. So let's take them up one by one. The first one is inventory. As the name suggests, it is all things that you have in your, or whatever you call as your inventory. They may be the products that you plan to sell, they may be the services that you plan to offer, or they may be the inventory of your raw materials, or they may be the inventory of the resources that you require for providing the service. So the waste over here would mean something like excess promotional content, spending too much on, let's say, advertisements when you don't need to, or having too many advertisements, excess stationery in your office, excess resources in your office, excess tools, or the things that you have rarely used. How many of you have seen something which is just lying down in our home and we have not used it? So that's an inventory which is just wasted. Or something which is to be repaired but you have not repaired for a long time, that comes under inventory. People complain, and mothers all over the world complain about food being wasted, and that's another example in your home, about excess of food being prepared and not taking into consideration how much people can eat, and then it goes waste in the kitchen. Then we have motion, which is about movement. So just to grab one file, if you have to walk down a kilometer, that's a waste of your motion and movement and energy. If you have people in your office or wherever you work, searching for some information or data, or searching for tools for, so the activity to be done might take a minute, but you spend 5 minutes searching for it. Now that's a waste. Or you have a poorly organized workspace. Well, though in brackets you may not know that it's poorly managed or organized, but where people find it very difficult to quickly accomplish their work. Unnecessary meetings, maybe, just because you have set a period of frequency for them without looking at the need, or maybe too many clicks. You want to buy something and then you just click, 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 and then finally you end up saying, oh, what the hell, I just go out of it. So by the time you reach your destination, you have had too much of movement. So that's wastage of the motion. This is something that you can have a look, especially those who are from the manufacturing sections. They may have a look at their processes, the upstream and downstream both, and then note down if there are any such kind of examples. Over processing should be simple. It's like maybe you have excess of process steps which are redundant, or there's repeat information that you're analyzing. Because remember, all analyzing takes a lot of efforts. Or you're processing the food too much when it is not necessary. Like somebody would keep on peeling off the skin of a fruit when people are okay with eating them just like that. So that could be some example from our home about over processing. That's another waste. Overproduction. You may not realize and you may not believe that you could be overproducing, but it's not about. So inventory would be producing too many things, but or too many different things, but overproduction would be producing too much of something. So it may be just a one thing that you may be producing or one service that you may be giving, but it's about having too much of preparation and too much of resources that you put in for this. Or there are some unsold inventories that may be lying down in the godown. So that's about overproduction. Those are the signs of overproduction and waste. Waiting, uh, long approval cycles, which may be necessary, but you ought to look at whether you can uh, shorten those approval cycles without any compromise on the quality or the security or integrity of information. uh, Whenever you have to have a lot of queues. So when you wait outside a hotel, that's a waiting time and that's a waste. Waiting can lead to a loss, a direct loss, because you might have customers that simply go away without waiting. Or it may be one process waiting to start unless the previous process can start, something like in a waterfall model, though there are also advantages of this waterfall model. So that can be one example of waiting. And transport. Transport is essential. Transport ensures that you can deliver your goods and services from the production unit to wherever it is that you have your customers. However, it is more about the internal transport also. So let's say you have two processes in your organization, but uh, from point A to point B, there is a movement of files, there is movement of people. Sometimes there are two factory units located far from each other, but the process is connected. They have the same process, they're part of the same process. In that case, you may have a transportation waste. So too much distance could be one, or maybe transportation which is not required, or you could deliver the service in the required SLAs or timelines if you use trucks, but you're using a plane, which means that you're spending much more when it is not required. That could be another example of transport waste. And the last one, but not the least, which is defects. I hope we don't have to talk about that. Defects is anything internal or external which definitely leads to efforts, and efforts finally lead to cost. So when you minimize your defects, you tend to minimize your cost. Initially, there may be a cost over it because you have to prepare the people to make less defects, but then eventually you get a benefit of cost reduction. So this is something that we all are aware about. Okay, some more concepts. And how could we not talk about cost of poor quality? Because that's what we have been talking about. Here, the quality is not only about software or hardware, it's about anything that you produce. Some of the universal definition of cost of poor quality tends to take note of the costs involved in four parameters, and they are cost of external failures. It means when a product has gone out from production to the customer and then there are defects or failures and customer complaints which you have to take care of. That's a waste. Internal failures is just like the internal defects. So the defects that you identify or the issues that you identify before a product reaches a customer or before the product gets delivered. Appraisal cost is nothing but or your audit cost, which can be internal and external again, where you have some quality control appraisals and audits. And when you tend to spend much more than what is required, so you increase the scope so much because when in fact you could have actually reduced the scope by ensuring that you have a stringent internal quality management system. So that's another waste for you. Preventive actions. The preventive actions that you take can sometimes be costly. So they are linked with what is called as risk management, which is why you should not put efforts on just about all the risks that you see. That's maybe not a wise thing to do. You can always prioritize that the risk for which you are taking this preventive or the mitigation steps, and then target only those which have the maximum impact and also the return on investment. Okay, let's go ahead again. If there are any questions, please feel free again to use the chat box. It's just for you. We would love to hear from you and see your questions. But again, please, I request everybody to keep yourself on mute and switch off the videos in case they're still on. Okay, so let's talk about data now. Since if you are going to use any technique, including Six Sigma, you need data. What data to measure is one big question. You might not have all the right kind of data with you today, which can help you to identify the factors of costs. But I hope that when we go through this presentation, you can know some of the areas where you can measure the data. So have you defined the measuring unit? Surprisingly, what we find that from our experience that ask somebody, what is the unit of something that you're measuring, and ask 10 people in different times, and you may get 10 different answers. So it is necessary to know and define clearly the measuring units and also the limitations of measuring something. And what's your source of data? Because it may be biased to makes you seem that, okay, hey, we don't have any cost problems. We are doing well. We are rich. So your source of data here plays a very important role. Are you doing adequate observations? Is it like one data point, which is not something which can be called as a data point as well? Because most statistical techniques require some minimum number of data points. And for your statistics, in any case, for you to be absolutely confident, you need to have adequate observations. Because once you do an observations over a certain long period of time, you can be sure about the consistency of an issue or whether the issue is just localized and temporary. Do your observations cover all the groups or phases or stages of a process, or you're only focusing on one part, so you're focusing on the upstream and not the downstream? Is that what is happening? So you need to be very careful about this. You need to really make sure that you're covering all the relevant uh, groups and phases and stages. This is where the concept of sampling comes in, because it's not possible that we analyze each and everything or every point that we measure. So you must have some good uh, sampling techniques also that you could use. Okay, we have a question over here. The question says that we want to know more about the appraisal cost in cost of poor quality. Well, so if you have planned and if you are having regular audits, internal as well as external, that's very good. But then please see that whether their scope, the depth, and the timelines are so much that you could have actually found out some basic issues in your process on your own. This is very necessary. Remember, you may control the internal appraisal cost, but external costs may be difficult to contain or control. And this is when an organization feels the requirement to repeatedly go for external audits. Uh, in some way, because people may say, okay, there's an external agency, so we don't need to do anything internally. Now, that's a bad decision. That may not be the good decision, and it may end up, giving costs too many costs for you. So, and that is again what is called as an external cost. So I hope this question is answered. If not, please let me know again. And in the meanwhile, we will move ahead. So let's talk about some techniques that you could use in the define phase. So there is a matrix or a sort of a table with lot of rows and columns. It's called a Pugh matrix, not a Pugh matrix as maybe some of you would pronounce it. It's a Pugh matrix. What a Pugh matrix does is essentially it lists what are your criteria, your processes, and some of the things that you are doing, and then whether they're good for your or impacting your costs, whether they impact the quality, whether they are critical to your knowledge, critical to growth. So when you do this in the define phase, you are simply defining what could be some of your critical objectives and critical processes. So what you see is just an example. Uh, some of these processes are also the attributes, meaning that you can directly measure them, like what you have delivery schedule variance, for example. Some of them might require some measurements to be attached, for example, procurement quality, which could mean a lot of things. So you need to actually find out what are the things that you may measure. But this is one matrix that can help you to prioritize your processes, because when you talk about cost variance, it makes no sense to address them on the processes which are not on priority. Measure phase, let's talk about the measure phase. The goal of this phase is to find the whys. So in statistics, we have the concept of X and Y, where Y is whatever you are targeting. Y is the target process. What is it that you want to control? So in our case, it's the cost, the cost reduction. That is what you want to do. So in this phase, you collect your data. The word here you can see is baseline data. Baseline is something of a collection of data over a period of time, a specified period of time. Or it could be data on issues and the problem statement parameters. So you must collect as much data as possible on these things. As I said, you have to use the sampling method if the population size is too big. You validate the data against the key sub-processes. So if I just go back this slide, in your Pugh matrix, these are the priorities processes or sub-processes that you have. So these are the processes on which you would measure your data and keep it ready. So identify key measures which are traceable to the sub processes. Now, if we enhance the Pugh matrix, you will see something like this. So on this table, we have kept those processes as the same. And then for each of these critical processes, you can have some, well, example measures. For example, you might measure schedule and schedule variation or variance. You may measure effort variation or effort variance. Something about procurement quality, it could be your supplier defect rate, procurement cycle time, delivery lead time. And then you can always do an analysis of how much they are critical to quality, critical to cost, again, which is our topic for today, how much they are critical to knowledge and growth and so on. And then probably when you take a sum of it, you could then select those which are having uh, the highest sum. Also, you could use this as one of the decision making tools or technique. So going back, this is what you do in the measure phase. Also, you analyze the patterns. So whenever you analyze the data, you may get some patterns, identify those patterns, and you improve on your measurements. Analyze phase talks about finding the X factors. So we spoke about the Y factors, which is the process that is your target. But then what are the other processes or sub processes that influence your Y or your target process? So that's what you do in the analyze phase. You perform something called as a correlation, which means that you identify if by changing my Y or changing my X, is there a proportionate or some kind of a change, identical change in Y. And if there is a statistically significant factor that I can identify. So in analyze phase, you perform the correlations. And you also detect which of your X caused the most significant effect on Y. So that means, in short, which process can impact a lot and contribute to a lot in cost reduction. This is what you find out by using some techniques of analyze phase. So in measure, we spoke about how you can use some of these measurements, and then many of these will lead to a good inputs on the cost. For example, you have cost variance over here. You have return on investment calculations over here. This could essentially help you to determine on where to focus with respect to cost control. From the analyze phase, one of the most popular diagrams that you all might have heard is the fishbone. It is also known as the Ishikawa diagram on the creator of this concept. It is also called as cause and effect diagram because it helps you to find what could be the potential causes of a particular effect. It's shaped like somewhat like a fish skeleton, which is why the name comes in. You must know the effect in order to find the cause. So, which is why we said at the start that your definition of the effect has to be very clear. It uses brainstorming, so you don't do it alone. That's something that you should not do. You must include the relevant people to do this technique. Let me get some questions at this point in time. I can see some of you have some questions. Oh, we have very good questions. One of the questions says that, does correlation mean causality? So a correlation, to satisfy, it will need three things. One is there should be a cause-effect relationship. It's not only when one quantity changes and the other changes, because things might change when they're not related at all. Secondly, there should be mathematical relationship between the two processes. And the third requirement is that there should be consistency in this relationship. So it's not that you see it today and that tomorrow it disappears. So if these three rules are satisfied, well, in that case, your correlation will definitely have a causality in it, because then cause and effect is satisfied. So I hope that's answered. So very good questions. Please do keep writing in the questions. It will help all the other participants also of this webinar. So moving ahead, let's look at some examples of the fish and the bone. So coming bullseye on the topic, so you have high production costs and you want to determine what could be the effects of this high production costs. So you do a brainstorming with your team. People who are expert in their areas would provide inputs based on these sections. These are the bones basically. So this is the head, the effect is the head, and measurements, material, personnel, methods, and machines, these are the bones. These are the bones, the main bones of this fish, or they are the sections. You could either brainstorm first without taking into consideration any of these sections and then later categorize. Or if you're very much clear about the possible sections or the bones, you could first define these sections and then inform the participants of the brainstorming session, and in which case they could actually you can target one by one each of these sections. But whichever way you do, I repeat, this is not an exercise that you could do alone. It could lead to bias. Let's look at some more example. So you may not always have cost as a direct effect to be taken, because there are sometimes indirect effects and which cause caused by the cost. For example, if you have high software defects, it is well known universally that of course that leads to high costs. But it is essential first that you know why you're getting those software defects. So these are some examples again of design. There could be incorrect designs. Maybe human beings are not following the standards that they should follow. So they have, they need, in which case they might need training. But a point to note again, if it's an external training, it may also require costs. People are not aware of the quality standards. You have unskilled labor. It may also have got something to do with the environment. People often complain that the quality is impacted when you cannot, when you don't have the required, uh, environment around you, and because the environment also directly impacts humans. And not only that, it is well known that your laptops and computers can heat up like anything if you don't have a cooling mechanism, either an inbuilt one or an external one. So these are environments that matter. Environment could also mean what is being provided by your organization. Maybe you have a low budget. There is a lack of required tools for quality control. These are many factors, or some of the factors that can directly contribute to defects or low quality. And remember, delays can also lead to cost. Incorrect methods, again, your requirements are not ambiguous the way you write. The testing process is not correct to find the defects until they go to the customer. So you need to find, you may need to have more peer reviews, but that's something that may not be happening. You may be reusing very less amount of things. So remember, when you reuse something, definitely it's expected that it has already undergone some tests. So in which case you must think about probably reusing those components or parts which have already undergone quality control. With respect to the manufacturing areas, for example, not necessarily to software, it could mean something costs coming in from high maintenance. It could mean use of some licensed software or hardware. It could mean excessive testings or the cost involved in buying the resources for testing. It could mean improper designing process, which might be eating up more fuel. It can be an improper internal quality audit process because that's where you spend your efforts. Again, human errors, which are something very common. Uh, Low efficiency of the machines that you are using, or maybe they have got old. So it's a known thing that as and when things become old, the efficiency decreases, or there are some redundant parts and machinery. So all of these factors could be potentially your cost factors. Let's go ahead. If there are any questions, please feel free. Okay, we got one beautiful question related to the cause and effect. That let's say we know that there are certain excess or processes which have an impact on your Y. How do we find out which of these has a greater impact on the Y? So beautiful question. Please stick to this question for this time. We are very soon going to see how you can exactly find that out. So thank you for this question. I appreciate this, but this is something that is also part of this webinar. So just stay put. All right. Now, about this fishbone diagrams that we saw, well, it looks very easy. Definitely, it is easy to draw. But remember, when we are talking about saving costs, if you do this exercise in an incorrect way, all the time that you spend in brainstorming and creating this beautiful design will all go waste. So let's look at some useful tips over here. Do not ever force fit any of the causes into the section. You might encounter that there is a cause which does not automatically fit into any of distinct sections. So in that case, you can either just mention the cause as a standalone cause, or that may be a chance to create a new section or a new section or a new element for the causes or new category of the causes. Then if some of your sections remain empty, don't worry. Your task is not to fill up those sections. Select your participants wisely. Remember, look at the processes that you're trying to control. Look at where you're trying to control the cost, and involve the people as said by Taichi, as you remember the quotation, and also what Bill Smith said, that if you want to improve the process, you have to talk to the people who are doing them. So select your participants wisely, and don't do it alone, because that's what I said, it's a bias. Set a time limit, because again, in the interest of this exercise, or you might you might just end up doing this exercise the whole day and not come up with anything in particular. So it's better to set some limits. You can also set some constraints, and how to define the success factors. When would you stop this exercise? And as I said, there are many techniques that come under each of these phases. In fact, some of the techniques that you will see in other phases of the DMAIC, or define, measure, analyze, improve, and control. So some of these techniques don't necessarily fall into only one of those phases. They can be used in multiple phases also. All right. So let's go ahead and see what else we can talk about. One logical end to the fishbone analysis or Ishikawa analysis is, once you identify the categories of the causes, it is essential to do a 5 why analysis. The difference is that in fishbone, you would just look at the main cause, the first cause or the first level cause. But if you really want to ensure that you don't repeat those causes and essentially the effects, please do a 5 why analysis. A 5 why analysis is, well, it says that people claim that when you ask a question why 5 times, at least in the fifth time, you would come to know the root cause. So, what caused software design to be faulty? Well, first why would be ambiguous requirements. Second why would be, the person who is writing the requirements is not skilled. Third why could be we are not provided sufficient training, and then that could be the end of it. So make sure that you support this fishbone analysis with a 5 why analysis. Okay, let me check if there are any more questions. Let's take up some questions if there are. So any other tools other than fishbone analysis? Yes, so you will see many tools that we can use either in the analyze phase or the measure phase or the control phase. So this is what we will see. So thank you for this question. Yes, definitely the answer is yes. Okay, let's go to measure. Now, Pareto is one technique which can be used in the measure phase as well as in the analyze phase. And we will just see why and how. So what Pareto says is that roughly, this word is very important, roughly 80% of the consequences or the effects come from only 20% of the causes, which means 80% of the issues or defects can come from only 20% of the causes. And thus, it means that 80% of the cost comes from 20% of the causes. So this is a very powerful statement. If you are doing this analysis correctly, if you have the right kind of data, you can definitely come to know and identify this 20% of the causes. So this is the principle of a Pareto technique. So let's take an example. Remember, though the examples might sound from some particular industry, essentially it could be from any industry. As I said, it's about measuring and collecting and documenting the right kind of data. So we have a data where we have type of defects over here, and then we have how many such defects have happened. So that's a count. Remember, in Pareto, we need the count because it takes care of something called as a frequency of some issue happening again and again. So we have the data on the defects, and you could actually categorize in the way of the industry that you come from. It could be software defects or some of those, the defects that we saw in the fishbone. You could actually put them here, and then count which one of them have happened how many times. You could also do a priority in terms of what about the cost? Which of them are actually contributing to a lot of costs? So when we use this data in a Pareto, this is something that it looks when you use the data. I will show how you use the Pareto using a tool called as Minitab. But for now, for a second, just you can have a look that this is what is the output of the Pareto. You can see that if you are going with only the count of the defects, these are the type of defects, and this is the frequency distribution for the bars, and this is the percentile of what percentage of the total or a cumulative percentage is taken up by each of these type of defects. So going by the 80-20 rule, let's say that you have to drop a line from the 80 to wherever it makes in the x-axis. You could actually find out which are the main 20% of the the things that you should identify. For example, let's draw, well, not quite a straight line. Good. So what we have seen is this area, which is comprised of mainly the missing part errors and the electrical errors. If you look at the percentages over here below, which is an output, you could see that just these two, they are the main contributors. Okay. Uh, let's look at the interpretation of this, then it will be clear. Let me remove those lines. We don't need those lines anymore. So here, when you look at the count, your priority is only the count. So your priority is just to reduce the count. And the first two defect types would contribute almost about 70% of the total defects, which means they could be your priority. But you're only focusing on the count here. You're not necessarily focusing on the costs involved in solving or resolving those errors. So we will also look at how can you introduce the cost factor and then do this analysis again. First, let me show you how you can do this Pareto very quickly. In the meanwhile, I'll be also looking at some questions if there are. Okay, so we have no questions, new questions. Let me go to the tool so that we can see how you can actually use the Pareto. I hope the screen is visible. And we have some data for the missing parts as we saw. So this is the data over here. And we have to use the Pareto now. So you may, again, it is not necessary that you have to be a statistical expert, but if you have a tool, something like this, you could use it for your analysis. So we have an option of a Pareto chart. Very good. And let me put in the defects data over here. And the frequency is my count. So when I run this, what I essentially get is a Pareto, the kind of the graph that you saw, or the chart that you saw. This is as simple as that. There are just three steps to this. So this is exactly the output that that we saw on the slides. Let me go back to the slide so we can explain further how you can take it up. So remember, we are still not spoken about the cost. This is just about controlling the number of defects where count is priority. So how can you introduce the costs? So we can elaborate this data. So we have the same data, but now you calculate the cost per occurrence of each defect. Okay, so you're essentially boiling down to what it requires in terms of the cost components for each of these defects. When you have this data, you could simply multiply the count and the cost, and you would get a product like the cost versus the count. If you use this, or if you use only the cost, for example, so there's two ways. You can only use the cost, or you could use the cost with the count. This particular Pareto that you see is, again, only the cost. You can see now that the priorities have changed. Now we have movement errors, which have taken the place of missing part, and missing part has actually gone, electrical errors have gone, like at the bottom. So in this case also, there's a good contribution by the first two type of errors, but that is with respect to the cost only. So if cost is your priority, then the first two defects would be something that you should target. But mind you that if the cost, the actual average cost is the same, it is then that you can actually target with the type. But as you can see in the practical case and also the example that we have considered, the cost is not the same. Some of these errors require more costs in terms of correcting them, which is why the best thing is to use a Pareto with the cost and the count. So let's see how a Pareto would look. Same steps, so I'm not showing those steps again. So now you have considered the cost into the account data, and there now it tells you that shows something like movement errors, which is the topmost contributor, followed by electrical errors and misaligned gears. And as you can see, it's showing that the chart is about count and the cost. So here, again, your reducing cost is your priority, and first two types contribute to about 50% of the total, but here we are using the cost per occurrence. So this is one way where you could use a Pareto in order to identify the cost guzzlers in your process. Do we have any questions? Then I'd like to take them up. One question is the Pareto technique a subsequent of fishbone analysis, or these two are used in different situations? So, good question, first of all. Thank you for asking this question. Remember that in Pareto, you only target the defects. You're not doing an analysis of the causes, because when you prioritize which defects you want to focus on, and then if you do the fishbone analysis or any analysis which can let you find the causes, it is more cost efficient and it is more effort efficient. So it's actually the other way around. So do a Pareto if you categorize your your defects, and then find out the top 2 or 3 defect types if you can do that, and then find out why those defects are occurring, and then you target the cause of these defects, you take an action, and then hopefully you would not have those defects again. Okay, so good questions. Keep the questions coming. Let's move ahead quickly. Another tool that you could use in the analyze phase itself is a matrix plot. What it does is you can analyze the variation of all your processes. So let's say you have data on 5, 6, or 7 processes, and if you want to study how these people or children behave together, when they are put together in one room, so you could use this technique. You can identify the statistically significant correlations. That means you don't go by feeling, but you use the statistics to actually prove that, hey, I know that this particular X3 is related with my Y. You can check how different variables influence each other. So it's not only the influence of X on Y, but you should also know how internally each processes are impacting one another. And in correlation, there can be 2 types. One is positive and one is negative. Positive means as X increases, your Y increases. And negative is the exact opposite of it. For example, let me show. Just see where the graph has gone. Okay, we'll come to that. So essentially, you have to remember that correlations can be negative as well as positive. So if it's a cost, that is your Y, and if there's a negative correlation, it means that you have to improve or increase that particular process, and vice versa. So let's look at how a matrix plot would look like. So this is our data, and you have a lead time, which is essentially the time from initiation to completion. Then you have some waiting times, Then you have the costs associated with this process. You also have a setup time, and we have some parameters which we talk about the different products or different types of the products. So what happens when you use a matrix plot? Well, you get something like this as an output. Again, this is an output from Minitab. As you can see, we have cost over here, and each of these boxes correspond to some of the process. So the way to read is like cost versus lead time, cost versus waiting time, cost versus setup time, and also internally, so lead time versus waiting time, etc. And what do you see? Uh, if we focus, let's say, on one interesting part, which is something about this, that looks like quite a good straight line, almost like a straight line, which means that you could probably focus on setup time. You might be feeling that, okay, my lead time is more important in terms of reducing the cost, but that may not be the case, as in this example. So with this data that we have, it shows that the setup time has the greatest influence on the cost. More the setup time, more is the cost. So this is a positive correlation that I was talking about. All right, so let's undo this. Now, let's talk something about the improve phase. So we have essentially spoken on define, measure, and analyze. As I said again, I repeat that there are few more techniques that can be used on either of these phases. So let's talk about improve. So in improve, you evaluate the possible solutions based on the outputs that you get from analyze phase. So if you know that my setup time is impacting my cost as the greatest, then well, we find solutions to minimize the setup time. Create action plans, use pilots. Why pilot? Because you might end up, buying something from the market or investing a lot of time only to realize after end of the quarter that, hey, that's not work. So a piloting is a very safe thing to do, but then it will again require you to understand how to create a pilot plan. So use a pilot plan in this improve phase, decide the action plans, and also evaluate the effect of the actions. So if the actions or if the effect is not up to the mark or not as per your expectations, you would actually give this as an input to the analyze phase again. So maybe you need to analyze more, or you need to analyze some more things rather than just the things that you were analyzing so far. In which case, when you perform the analyze phase again, that should be an input to the improve phase. So it's kind of a cyclic motion between the analyze and the improve. So let's look at another technique now, which can be used for in the analyze phase as well as the improve phase. This technique is called as regression. It's a relation basically. It talks about a correlation. It helps you to understand not just whether an X is related with a Y or whether process 1 is related with the process 2, but what exactly is the nature of the relation? Is it negative, positive, and how deep? So it's essentially a mathematical relation between variables. So you would get an equation here. The dependent variables are, so Y is called as a dependent variable because it depends on the X factors. The X factors have to be independent, which means that they should not influence each other. They should only influence the Y. And there's only one target, which is, so for each equation, you would have only one target or one Y, but there could be multiple independent variables as well. So let's have a look at how we can do the regression. Well, so this is one output. productivity and the situation demands right now that we have, that we keep ourselves safe from the coronavirus. Uh, we get messages every day, we get news every day, and well, if you feel that it impacts your productivity, uh, it's good time to check. So this can help you to check if that's really the case. As you can see from the output, it's a clear straight line, which means that my productivity will fall as long as, as and when I get more coronavirus uh, messages. So that's something that can help you to focus on what not to be done or what's to be minimized. Let's take some serious cases as well. So again, we will look at the same data, and we will use the regression for finding out the nature of the relation between the x and the y. Some tips, I'll show how to do this, but some tips before that. There's something called as a p-value, which you have to focus on. Don't worry about learning anything about the p-value. This is not a statistics course, but just remember that if the p-value is less than this magic number, which is a 0.05, then you can be sure that the regression equation that you get is a statistically significant one. And if more than, well, for those x's which are showing a value more than 0.05, you have to eliminate. Remember, this is useful when you have multiple processes which you feel can impact your cost, but you're not sure if, and there was a question again that how do I know which one is more significant? So this is what you do. This is the test that you can use to determine the significant variables. So it's a two-step process. You find out those processes which are not significant, which means you eliminate and you rerun this regression. And then whatever output you get should be a good fit for you to take the decisions. Regression is also called as a predictive model because you can actually predict what can be your y or cost, if that is your y, if you know the x today. So that's the beauty of this technique. Also, there is a parameter called as R square. I'll show it in some time. Any value greater than 60, which means, well, you're good to go. So let's come out of these numbers and let's have a look. So when you do an analysis of variation, or when you do a regression, you would get so an output something like this. So you have total lead time, waiting time, and setting time. If you remember, we have used the same example. If you see clearly, there is a table of p-values. And among these three processes, which is total lead time, waiting time, and setup time, the setup time has p-value as less than 0.05, which means that this is something which is a good process to consider, which can impact the cost. Which means also that the other two variables, which are having the p-value more than 0.05, should be eliminated from your analysis. So this is an equation. These are the equations that you get. Something like cost will be equal to some constant. This is one process, this is another process, and this is the third process. This is assuming that you keep all these three processes in this equation. But what if we eliminate those processes which are not significant? So let's go to the elimination round. Now, when we eliminate the other two variables and rerun this regression equation, you get an equation something like this. So cost equals some number, which is a constant, and again some numerical value multiplied by the setup time. As you can see, the setup time has a plus, which means there's a positive correlation. So you can be now statistically sure that if you control your setup time, it will have a definite impact or a significant impact on the cost. You could also identify some more variables. For example, I have added this process of reuse. The more you reuse, the more the better. This is what I feel, right? But let's not go into feelings. What if I have the data And what if I run this regression and then check if I'm correct or not? So when I rerun this regression using another variable called variable called as reuse, I see that both these variables are equally significant. So thus I can now assume or get an equation which contains two variables, which is my setup time as well as the reuse. And again, if you can see, the reuse has a negative value, which means that the more you reuse, the less will be the cost. Whereas the more is the setup time, the more is the cost. Why you are doing this equation? Why you need statistics? Because you need to be sure when you're talking about a large amount of money, whether taking an action will really help or not. So for the paucity of time, we will just continue quickly. But at this point, also let me see if we have any questions. Okay, we don't have more questions. So let's move ahead. We've come to the last phase of the Six Sigma phases, which is control. Uh, as the name suggests, this phase would actually help you to put the necessary control over your processes, but that also includes the management processes, not just your development or manufacturing processes. One expected output is that you standardize, because the control should not be for 1 day or 1 hour. How do you ensure that you have the control for a long term? You standardize the process and you set up some proactive mechanisms for cost detection. So this is a real-time monitoring phase. You monitor, you control, you take action, you improve, and then you sustain by standardizing, and therefore you bring in some control. Let's look at some examples. So we have a technique called as control charts. You can see A, I, and C, which means these control charts can be used for analyze, improve, as well as control phases. So control charts will tell you whether your process is in control or not. It maps the process variation over time, and it automatically calculates something called as control limits. Remember, when you define something as a limit, those are called as specification limits because you specify, right? But control limits are the process, these are the voice of the process. Specification limits can be voice of the customer or voice of the business. So a control chart will show you what are the control limits, and if any point is outside the control limit, well, then you can say that your process is not stable. So it's a process stability check also. And because it can be used real time, as and when you have a data, you just go on plotting the control chart, and it can help you to take some real time actions. Let me go over to Minitab again, and I'll quickly show you how you can actually draw a control chart. So we have some data on the defects. You can see that we have dates, and we have the number of defects. So we just have those two simple columns. We'll be using this column for generating the control chart. So you go to stat, you go to control charts, because and you select individuals, and remember this type of control chart called as IMR, which stands for individual and moving range. Select this chart, and you put in the variables that you want to kind of target. So we have this defects 1, and that's it. So I get this chart, which you also saw on the slide. As you can see a red point over here. this is essentially called as an outlier, which means that there's something happening over here, which is also contributing to the mean. Remember, the higher the point, the higher will be the mean. And since your defects would contribute to cost, it is prudent enough to understand what caused this, this spike or this particular red mark, and then identify the causes using the techniques that you have seen before, take some actions, and then you rerun, because this is a real-time chart, right? So you go on doing this chart. So this is how you interpret this control chart. And going back to our presentation, this was exactly the output that you saw. If you take the action on this outlier, so you identify what caused the issue, hopefully you will not have this issue again, which means that your graph should look something like this, because then it means that you have removed the cause of this variation. And well, this will make you happy, right? But what if you continue to get this high mean of defect, and no matter what you do, you get this mean and you cannot reduce this mean? So what is happening is you did remove the special, that outlier, but you're not able to target this mean. You're not able to reduce this mean. So what do you do? Because it's adding up to your costs. So what do you do? Now remember, the data that we have is for the combined defects. What if you categorize the defects further into the type of defects? Because probably as a total, the defects might not be too many that can, make you see a red point over here. But you can't see just by looking at this graph. It's very hard to say that whether there are underlying defects hidden inside. So what you do is you break up each of these data point into the type of defects and then rerun this chart. So we have done exactly that. And let's see what you see when you rerun this chart using this new type of data. So we categorize the defects into design defects, algorithm-based defects, or they may be function defects. I have just taken some wild examples just to explain that sometimes data classification or stratification is essential. Now what you see is these data points come from the same data as from the previous slide. So here, no problem, right? But high mean, so high costs. And here, you now identify that at least from the two types, which is design and algorithm, you have some outliers. One over here, I hope you can see it, and another over just above the top. But this third type seems to be okay, so which means that you may not do anything for this. Now you can also target these outliers and identify the causes, and then hopefully come up with solutions to have lesser number of defects and put your process back on the stability route and hopefully control your costs. Let me just check if there are any questions. Right, so we take up questions as and when they come. Moving ahead. One of the last final techniques that you can use is not something that can help you to detect, but something that can help you to predict. Because remember, in cost analysis, even prediction is important. We are going to talk about two techniques which use probability as the function. One is called as the cumulative probability, and one is called as the inverse probability. Let me show it one by one. So in cumulative probability, you know the mean. The mean of what? Maybe the mean of cost variance. You know the standard deviation. You can always use tools like Minitab to find the standard deviation. It's easy. You just have to fill up the data. So you know the mean, you know the standard deviation, but you want to know if a particular value of cost variance is possible or not, and what is the probability of achieving it. So in that case, you use this technique called as cumulative probability. And as a jodidar to this technique, you have inverse cumulative probability. Again, you know the mean, you know the standard deviation, but uh, you just have a probability in mind that the way we say in normal life, what is the 90% probability of achieving something? So you want to know, if I'm 90% confident about my data, what will be the cost variance? Or if I'm 99% confident about my data, what will be the cost variance? So in this case, you use the inverse cumulative probability function. I'll go over to the tool because that's easier to show, and that would be beneficial to all the participants who are here with us. Uh, so let me first open that. You go to calc, CALC, calculations, you go to probability distributions. For those of you who might know, these are all the types of distributions that are there in the world. We will assume that there is normal distribution. And even if you're not aware of the distributions, just remember that you have to select normal distribution. So let's say that you want to find what should be the the cost variance and to expect. So you have to click on cumulative probability and ignore this inverse for now. You have to enter the mean value, and let's say that your cost variance comes to about, let's say, 30% as a mean, and your standard deviation is very high because you have just started measuring things, and so I'll put it as 2 over here. Now in this case, if you put some value like, let's say, 25, so I want to know if what is the probability of achieving the value as 25. You select the option of input constant, because constant means wherever you write a value. Let's put 25 and let's run this. What you see as an output here is this. Here is the value that you have entered, and you can see some number, which is the big number, but you have to, this is the percentage value converted into fraction. So if I multiply this into 100, it's less than 1% probability that I will have 25 as the cost variance. Let's do this again, and let's put some other value. Let's put 60 as the cost variance. And now it shows 1. So 1 means 100%. Why did that happen? Remember, your standard deviation is 2 and your mean is about 30. So that means on equal sides, on the equal side, on the both sides of the mean, you have this spread of the process. So a high cost variance is more probable in your case. But I also want to know if I can maintain this 30 as a mean, and because that can be my target. So in which case, if you see over here, you will see it says 0.5, which means 50%. So there are 50% chances of you achieving the mean as the cost variance. Now, let's take up the reverse case or the inverse case, where you have some confidence percentage in mind and you want to know what's the likely value based on this mean and the standard deviation. So then you just click on inverse cumulative probability, and instead of the value, you convert the percentage of confidence into a fraction. So if it's 90%, I'll put it as 0.9. And then it tells me that the most likely value of, 90%, there is 90% probability of having a cost variance value of 32.5. So I don't have a value in mind, but I have a confidence interval. What happens if I put it as 0.99, because that's the maximum that it can take? So let's talk about 100% probability, or almost 100% probability. Well, then it's giving me the value of 34 over here. Thus, you can use these techniques whenever you have your data, you know the mean and you know standard deviation, but that's about everything that you can do. And it is just for testing your confidence, because your feelings may not be relevant in terms of the actual data. So this was the outputs that some of the outputs that we saw. So instead of 30, instead of the image says 29, and then we asked the tool what's the probability of having 25 as the value, and it says about 30%. So depending on the data, you will get these outputs. If you have if you use Minitab, and if you are inputting all these values, so instead of the input constant, you can have input column, in which case you can point the Minitab to this column where you have this data. So you have the X values over here, as you can see, and for each value, it will give you the percentage of probability. Same thing with the inverse probability. Right, and there are other techniques as well, which are not part of this webinar because time is running out. You have TQM, Total Quality Management, and wherein the whole team, it's not one person, it's like the whole people who are involved in the process, they all come together for quality management. And this is one technique that you could probably take it up. You can also look at Pokayoke. It makes mistake proofing. Have you ever tried, putting your USB drive or a pen drive in a, ulta? So it's not possible because the laptop is made in such a way that it has this mistake proofing. So in Pokayoke, you prevent, you make the infrastructure or a framework such that mistakes just don't happen. Value stream mapping, it is something very powerful, but it takes time. That's one area under Six Sigma that you could also use, where you look at each process element and you assign some measures to each process element, including, for example, if you're calling somebody in your company, what's the average time that you spend in calling? So value stream mapping actually looks at each process element. Lean Six Sigma, we have been talking about that. That's another thing that you could use and learn about it. And I hope that it can also, help you to do something with respect to the cost control. Well, something non-statistical is automation. There are huge costs involved, no doubt, in automation. But if you're looking at consistency and cost control in the long run, then automation is one good thing to have. So that's about it. If so, I'd like to give some acknowledgements and some references, because as I said at the start of this webinar, there are great minds who have put their blood and sweat into giving us this, opportunity where we can just connect for 40 minutes and talk about the techniques. But those people have spent 40 hours or more and years. So some of these references, I'll just keep this on for a minute. That is my duty to showcase them. And it also means you could also refer some of these beautiful articles. It can help you, those of you who are anyways doing with or dealing with quality control. So feel free to, refer them. And I hope you get good knowledge out of them. And of course, I would like to acknowledge my colleagues in CUNIX for good support for this webinar and the coordinations. We'll take some questions. Until then, I'll just put you into my contact slide. So this is my contact. This is my email address. Feel free to ask questions. Anything about process improvement, I'll be glad to take them up. And this is showcasing some of our other offerings and expertise areas. In the meantime, I will also look at the chat. So I'll just keep this slide on for a moment. We have questions related to how much raw data is necessary, or for pivoting. I take it as a piloting. So remember that if your measure is as raw as possible, it means that it is reflecting the real process. So you may categorize the raw data initially and then decide on sampling, and then decide on the techniques using the sequence that that we have just seen. So thank you for this question. If there are more questions, we can take them up now. And of course, to all those of you who do not have any question, I really appreciate you joining in such difficult situations. I hope that you could use some of these techniques for at least ensuring and planning to reduce the cost in your areas, whichever area it is that you're targeting. Make sure that you have good data. Make sure that you use the correct sequence, and make sure that you do not introduce any kind of biasing. Okay, so let's go ahead, and you can reach us to my colleague who manages the InfoSecure division, Mr. Rohit Mali, and you have his email address and his phone number, and you also showed my email address and phone number, so you can feel free to please reach us on any of these contacts. Okay, so thank you very much for your time, and I believe that this was useful in terms of at least starting with some good data analysis. Uh, I'll close this session. We will let you know, we'll keep informed for those of you who have contacted us on any more webinars that you are planning in the future. And we would also appreciate and value the suggestions from your side with respect to some topics that you would like to see. If feasible, we can definitely think about it. But thank you for those who have asked the questions. That gives a good and greater insight, and it makes the session lively. So thank you very much, and please stay safe, and God bless you. Thank you very much.